We're almost done here. We have a couple more to look at. In these cases, the first thing we want to recognize is that power of 1/2, which we've been working with these a lot now. We now recognize really quickly that that is the square root. So we have the square root of y plus 1 over the square root of y minus 1. Now these almost are done. In this case, they're pretty darn close, except for the fact that we have a radical in our denominator. So just like before, when we have a radical in the denominator, we need to get it out by finding, again, we can't just multiply by our radical there. We need to find a conjugate. Now remember, the conjugate, normally if we have a constant plus our radical, say it was radical x, anytime you want to find the conjugate, we just change the sign here. So it'd be 1 minus square root of x. Because of the commutative property, this is the same as saying radical x plus 1, in which case, to find a conjugate, coming down, we would say radical x minus 1. Because all the time, all we're doing is just changing this sign. Or in this case, we changed, oh, I want a different color, we changed this sign. So they stay the same. Now, if you look at these, you'll notice that this is equal to this, but when we look at their conjugate, this one, or actually again, I'm going to use a different color, this one is the negative version of this. And how come they still work as conjugates? Well, it's because if you multiply the conjugate by both the numerator and the denominator, they'll still come out to the same answer. So again, as long as you're using the conjugate to multiply in both the numerator and the denominator, it doesn't matter that this one is the negative version of this. They'll still work out. So, looking back at our problem here, we need to multiply by the conjugate to rationalize our denominator. So, we can look at this as square root of y plus 1. And same thing up here, square root of y plus 1. Now when we FOIL this out, y times y, or square root of y times square root of y becomes y. Square root of y times positive 1 is positive square root of y. Negative 1 times square root of y is negative square root of y. And negative 1 times positive 1 is negative 1, in which case these two subtract out, and our new denominator then is just going to be y minus 1. From here, we now also need to look at FOILing out the top. Y times, or square root of y times square root of y is y. Square root of y times 1 is square root of y. 1 times square root of y is the square root of y. And 1 times 1 is 1. We're not quite finished. We want to make sure we combine the like terms. So we'd have y plus 2 square roots of y plus 1. And this then is our numerator. Y plus 1. I like putting the radicals at the end. You don't necessarily have to, but a lot of people like it. It just keeps things nice and neat. So in this case, this is our final answer. Moving right along. There we are. I want to keep that up there actually. I'm going to erase this work. And we'll move this one over to deal with. Again, we notice this as square root of m minus 1 and square root of m plus 1. So it's very similar to the one we worked with. Whereas before we had a plus 1 on top and a minus 1 on bottom, now they're switched. But we know exactly what to do in these cases. We multiply by the conjugate still. So in this case, we would be multiplying by root m minus 1 and root m minus 1. Again, FOILing these out. By now we should notice that anytime we FOIL out, we get this number squared and this number squared but because it's times a negative, it's the negative version. So our bottom, again, anytime you multiply the denominator by the conjugate, we get the first number squared, so m, because square root of m squared, which comes back to m, and minus 1, because 1 squared equals 1, but because we're multiplying it by this negative, it would actually become a negative 1. Oops, I want to erase that. Now from here, foiling out the top, square root of m times square root of m is m. Square root of m times negative 1 is minus square root of m. The negative 1 times square root of m is another minus square root of m. Negative 1 times negative 1 is positive 1. Combining our like terms, and we have m minus 2 square roots of m plus 1. And again, when we rewrite this, I like putting the radicals at the end, so I'm going to say m plus 1 minus 2 square roots of m. So in this case, this becomes our final answer.